Okay, good day, everybody. My name is Ted Letofsky, and I am an architect here with Evolving Solutions.
Good morning, good day, everybody. I am Steve Solon. I am a storage solutions architect with IBM.
And we're here today to talk about the IBM Flash Systems family. To do that, we're going to need to talk a little bit about its heritage.
So the heritage, part of the heritage of this that starts with the Spectrum Virtualized software, which goes all the way back to our SAN volume controller. We released the first version in 2003. We have worked through 11 different hardware generations and a bunch of different software generations of that. But what the SAN volume controller does, you can think of it as a storage hypervisor. So it it sits between the server and the storage, and it abstracts a lot of the characteristics of the storage so that the server only sees the characteristics of the SAN volume controller. And what it does then is it takes the storage behind it, and currently we're up to about 500, 550 different supported storage arrays behind it, carves those both volumes up into extents, and it then makes volumes for the server to see out of those extents. And then it manages those extents. So I can completely change the storage behind the SAN volume controller without the host ever knowing about it. Because again, it sees the characteristics and the behavior of the SVC, or that device that's a 2145 type. It doesn't see the behavior of what's behind it.
So one of the things that we should probably talk about for a moment is that code base is also capable of being used on storage that already has existing data. So we can insert the SVC directly into the IO path for existing storage LUNs so that we can do things like mirror that storage onto other storage or replicate that data out into another storage environment, or even now out into a cloud.
Right. So what we've done, we've taken that software and then we've grown it, we've expanded it. I have 3 different platforms now that I run that software on. I have the virtualization appliance, I have the storage controller, and now most recently I have Spectrum Virtualized for the public cloud. So I can run that same software with compatibility for all of those features and functions between all 3. And doesn't matter what's talking to what. An SVC can talk to the Spectrum Virtualized in the cloud, a 9200 or a 5100, it can talk to SVC, or it can talk to something in the cloud. And that gives customers a great deal of flexibility because they can pick the right storage controller, right? A low end, a mid range, or a high end, or they can use SVC with existing storage, and they can then have a very smooth transition to moving that to the cloud or doing DR in the cloud. There's a lot of flexibility and a lot of power in being able to create a process that works both on-prem and for my stuff in the cloud as well.
Awesome. So now we'll talk about the next product. IBM has a product family called Accelerate that was based on the XIV storage product. That product had an award-winning GUI, and that was a real game changer. It was based on the idea that storage should be easier to administer, and that the GUI performed very much the same functions that an administrator would perform if they were doing scripting out of a command line. And that's really important, because if you want to create a script but you're not really sure you know how yet, you can perform all of those functions in the GUI, then go into the event log later and actually copy paste those directly out into a script. So all of that functionality and that GUI also became part of the IBM Virtualized and the IBM Flash Systems family.
Yeah, and it's kind of funny because over the years, right, I've been doing storage for IBM for over about 25 years now. I've seen multiple attempts, internal attempts, to consolidate the GUI, and they failed miserably. And it wasn't until we acquired the GUI that came with XIV that we found something that we could agree upon, and now we've taken that look and feel and spread that across our entire portfolio. And that comes to our next acquisition, the next piece of the puzzle, or piece of the picture, is we acquired Texas Memory Systems in 2012. And one of the really cool things about having a dedicated research arm like we do is they go out and they look at the industry and they were involved in both the XIV acquisition as well as the Texas Memory System acquisition. They go out and they find those companies that have really cool, unique things, and then they say, hey, you should acquire this because this is something we can use across our entire portfolio. We can take advantage of. And the thing that Texas Memory System did better than anybody else is they have developed through a lot of generations. I think there are 36 generations now of hardware. They use very low latency storage, and they have a hardware data path to give access to that storage. And that becomes important because if I'm running software, I've got to have processor cycles to do that, and that takes time. And if I'm talking about a millisecond response time from a spinning drive and I add 100, 200 microseconds, I don't care so much. If I'm talking about RAM or flash storage that has, really, really fast response time, 200 microseconds, and I'm adding 150 microseconds, I'm almost doubling my response time. So having that hardware data path becomes very, very important. And these guys have engineered and done so much engineering with this that they've kind of done a couple different things and done it very, very well. First, they are able to take a very small failure of a device and mask it from the end user. Because said this for years, a storage device is at its most vulnerable when it's being serviced by human beings. So we don't want, and flash wears out. Those two things seem kind of incongruous, but with this engineering, I can handle failures at a very, very finite, small level, and I again hide them, hundreds of them, thousands of them, depending on where they sit, before I have to declare a flash core module as bad and then do a typical RAID rebuild. The other thing that this allows us to do is this allows us to put engineering around the NAND itself, because as NAND gets denser, it gets slower, and in some cases, it actually gets less reliable. Because to get denser, I've got to get smaller lithography, and that can create reliability issues. So the other thing that we've done here is we've done a lot of engineering around that so that that effect is hidden again from the customer. So you can get a very, very dense package, and it's going to, and we'll warranty it and or support it up through 7 years. So basically, we dare you to wear out our stuff because we don't think you can.
So basically, from an availability point of view, if I understand you correctly, what you're saying is because of the deep technical relationships that Texas Memory Systems and now IBM has with the actual chip manufacturers, we can improve the availability and reliability of the flash modules and the storage system as a whole, because we have a much richer understanding of how they work, how they wear, and how we can spare them out and perform things like wear leveling across them to make sure that they have a longer lifespan.
Yeah, we actually get better reliability than the manufacturers say we will get.
That's awesome. So, in summary, what is IBM Flash Systems? IBM Flash Systems is the merger between the IBM Spectrum Virtualized and SAN volume controller codebase, the IBM Accelerate and XIV storage GUI and scripting tools and backend, and the IBM Flash Core module technology that came out of the Texas Memory Systems universe in a modular, redundant, and storage-dense platform.
Absolutely.
And because that family allows customers to right-size their environment from Tier 3 deep archive all the way on up through Tier 0 enterprise, and now even makes cloud adoption possible because Flash Systems is interoperable with the rest of the IBM Spectrum Virtualized family.
Exactly right.
All right, thank you, everybody. We'll talk to you again.
See you later.